Hey guys, Miss Hybert here. Ready for a quick math lesson? Great. This is going to be a really interesting one. So this is part 2 of our lesson 8-2. Yesterday we talked about finding missing angles and how angles are used in real life by people like engineers, architects, construction workers, all types of different things, skateboarders, right? So today we're going to talk about another kind of angle. This kind of angle is a real thing. This is a real life example of how angles are working in the real world. But this type of angle is called field of vision, if you've ever heard of that. So a field of vision is really neat. So what a field of vision is, it's the angle that includes the area that you can see without moving your head. So let's try that out, okay? Everybody sit up nice and straight, and I want you to just look straight ahead, okay? Now, take your hand and put it right in front of your face. Hold it like a karate chop, okay? And I want you to put it out. Don't touch your face. Stick it out a little bit and set it like in line with your nose, okay? So it's like in the middle of your face, but a little ways out. Now, very slowly, take your hand and move it to the side. Do not move your eyes or your head, okay? You're very slowly moving your hand toward the side, like to line it up with your ear, okay? Do you still see your hand even though you're not moving your head or your eyes? Right, that's your field of vision. When something you can still see stuff on the side, right, without like turning your head to see it. That's like your peripheral vision. And that's called your field of vision. Now, if you put your hand back in the middle, you might even want to switch hands. If you put your hand back in the middle, karate chop style, okay? Now move to the other side. Yeah, you see how you can just still see it even though you didn't move your eyes or your head. Now, once you get like a little ways past your ear and past your shoulder, can you see your hand anymore? No, because it's outside of your field of vision. So again, that field of vision is the area that can be seen. It's that without moving your head or eyes. And that area, actually, if you can visualize it, makes an angle. Okay, and it makes an angle that some scientists are interested in measuring. So some scientists that might be concerned with your field of vision would be optometrists or ophthalmologists. Have you guys ever heard of those type of scientists? I'll give you a second to guess what an optometrist or an ophthalmologist does. If you said eye doctors, you got it. So now optometrists and ophthalmologists, there's a difference between them. Now, I had to look this up, but I'll tell you the difference. So an ophthalmologist is somebody that does eye surgery. Now, these types of scientists and doctors can do like vision services and eye exams, but their main focus is like surgery on your eyes. Like if you have something wrong with them, or maybe you have a condition that your eyes need some kind of surgery for, okay? And then there is an optometrist, okay? So optometrists, what they do is they're the doctors that you go see when you need glasses, or if you need to get your vision checked. You know, they put all those letters in front of you and tell you to read the different rows. Those guys are called optometrists, and these are two different types of scientists that are concerned with fields of vision. So if you think this is kind of a neat subject, maybe you could be an optometrist or an ophthalmologist one day. That would be a really cool job to have. So let's get started on our math journal page for today. So I'm on page 274 in our math journal. Let's take a look. It says the area that you can see without turning your head is called your field of vision. The area outside of the field of vision is the blind area. Look at the diagrams below to see the field of vision for different animals. Now, if you did what I asked you a second ago with your karate chop hand, you stuck your hand out here, and then you moved it this way or almost to your ear or at your ear, and then you stuck your hand here again and moved it this way, right? You were making a shape like this, and that shape is an angle. Does that angle look familiar to you based on what we talked about last time? Good, you're right. Look, that makes a straight angle. Now, how do you know that makes a straight angle? Did you notice that benchmark number? You're right. You notice that made a 180-degree angle, and we know that angles that measure 180 degrees are straight angles. Very cool. So humans have about 180-degree field of vision. Did you know that owls only have about 110-degree field of vision? Look at the angle shape that makes. Anybody know what kind of angle that would be? Good, obtuse. That is an obtuse angle. It's greater than 90 degrees. All right. Now, when I think of owls, I think of them having like really good vision, right? But look, if you notice, their field of vision is smaller than a human's. But you know what else owls do that they're really good at? They can turn their necks really far and turn their heads like almost all the way around, right? Can humans do that? No. So maybe that's what the owl makes up for with his field of vision. He doesn't have a very wide field of vision, but his neck and head can turn really easily and see. He can like turn almost all the way around without having to move his body, just his head. So interesting stuff there. Now let's take a look at this rat here. Oh my goodness. So we've got a little rat. What is its field of vision? 200 degrees. There it goes right there. Now, anybody know what type of angle that is? You're right. It's a reflex angle. Good. How do you know that's a reflex angle? Right, because it measures more than 180 degrees. Good review, guys. All right. So underneath all these different pictures of the human, the owl, the rat, we have a table. And this math journal is asking us to complete the table. We've got the animal, the field of vision, and then the blind area. Now, let's look back in our word problem. So we know what the field of vision is. It's that area that you can see without turning your head. But the area outside of that field of vision is the blind area. So guys, again, to find that blind area, that would be back here, right? For an owl, it would be all this stuff back here. And for a rat, it would be all this stuff back here. So really, again, all we're doing is having to find the missing angle. We're going to have to find what's missing. Here's the angle that we know. Here's the angle we know. Here's the angle we know. Now we got to find what's missing, okay? I think once you see how to do a couple of these, you'll get them no problem. You'll be like, oh, this is way easier than I thought, right? Now, notice what I drew here. Now, it's not very neat, but roughly what shape have I made here? You're right, a circle. Exactly. And we know, especially because it's a benchmark angle, but we talked about this the last lesson we had. A circle is how many degrees? Circle equals, you're right, 360 degrees. When you go from one point all the way around, that's 360 degrees. So to find the blind area that we're looking for, we're going to need to do what? Take a second to think about it. Good, and if you said subtraction, you're on the right track. So to find that blind area, we're going to take the angle measure that we already know and subtract it from 360. So let's do one for the best animal there is, a human, right? So all we do is we take the field of vision, or the angle that we know, and subtract it from 360. So I'm going to do my work over here on the side. So remember, when you are subtracting and setting up a subtraction problem, you always have to put the big number on top. Okay, so for most of these cases, 360 is, well, I'll give you a hint for all of them. 360 is going to be the biggest number every time, okay? So 360 is always going to go on top, and then just anytime you subtract, put the biggest number on top. Okay, we are set up. We're ready to go. So 0 minus 0, 0. All right, can you take away 6 from 8? Nope, you can't. Mark out the 6, make it a 16. Mark out the 3, make it a 2. Okay, what is 16 minus 8? 8, you're right. And then 2 minus 1 is 1. Very good. So now we have our angle measurement for the blind area of 180 degrees. Now take a look at that. Does that answer make sense? Oh, it makes perfect sense, because look, it's like that 360, that full circle. We know 180 divides that right in half. So yeah, we're definitely on the right track by getting 180 for the blind area left over. And you can kind of even visualize it right there. That looks like a straight angle, doesn't it? Okay, let's move on to the next one. I'll do a few more examples with you. The next one, we're going to be measuring a fox's blind area. So if a fox can see in a 260 degree field of vision, all we need to do to figure that out is take 360, our good trusty circle angle measurement, and subtract it from 260. Now, some of you might be able to do that in your head, but it's always good to practice and show your work. So 360, I'm putting my big number on top, minus 260. Okay, can't take 0 minus 0, 0. 6 minus 6 is 0, and 3 minus 2 is 1. You are left with 100 degrees in the blind area for a fox. All right, let's take a look at the horse. Probably one of my favorite animals. Now, if you notice, horses' eyes are kind of like on the side of their head. So, wow. Yeah, they do have a big field of vision, 357 degrees. Guys, how much is a full circle? 360, you're right. Wow, that's pretty darn close to being able to see all the way around them, huh? Horses are cool. So, to set that up as a subtraction problem, it would need to look like this. Put the big number on top, 360 minus 357. Okay, can you take away 0 from 7? No, you can't. Mark out the 0, make it a 10. Mark out the 6, make it a 5. All right, here we go. 10 minus 7 is 3. 5 minus 5 is 0. And 3 minus 3 is 0. Now, some of you could have done it the fast way and just counted up. You could have gotten 357 and said, well, I'm just going to count up and get my answer. 357, 358, 359, 360, and you get 3 as well. So you could do it either way. So there's only a 3-degree blind area. That is tiny, 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 tiny. That's a little bitty acute angle that a horse cannot see. So that's why you've got to be really careful when you walk behind a horse, because that's really, they can't see right directly behind them. So it kind of scares them sometimes. So always be careful around horses. Now I'll do this cat with you because it's a little bit different than what you're used to. Now look at this. The cat, it doesn't tell us the field of vision. What are we going to do? Are we going to freak out? Or do we still have everything we need to know to still figure this out? Yeah, we have everything that we need to know to figure this out. This time you're not going to find the blind area. You're just going to find the field of vision. And it's the same thing, okay? This is still a missing angle, so we treat it just the same. So instead of solving for this part of the chart, you're going to just solve for this part of the chart, and it's the same setup, okay? We're still going to take our trusty circle measure of 360 and minus that from the angle measure that we know. And whatever we get, whatever the difference is the answer for the missing angle, okay? So don't be worried that, oh no, it's a different part of the chart. It's the same process to figure it out. So let's figure out the cat's field of vision. So all you have to do again is take 300. Oh, that doesn't show up very well. I'm not going to use a green pen. Let's try yellow. 360, that shows up a little better, minus 160. Okay. 0 minus 0 is 0. 6 minus 6 is 0. And 3 minus 1 is 2. So for a cat, their field of vision is 200 degrees. So as you can see, the rest of these are going to be completed the exact same way. You're just going to take that missing, or you're just going to take the angle that you know, whether it be you know the blind area or you know the field of vision area, and minus it from 360, and you will get the answers that fill in the rest of the chart. Okay, now look at number 2. It says, what is the greatest size a field of vision could be? Okay, now as an animal, you can only see all the way around you, right? You can't really see any other way other than a full, complete circle, right? So if you know that the only seeing things you can see is what's all around you, front and back, that makes a full circle. So the answer for number 2 would be 3. Oh dear. The answer for number 2 would be 360 degrees. Now, how did I get that 360? Because you see, if you turn all the way around, you can make a full circle, and that's everything you can see. I know that a full circle equals 360 degrees. So I want to hear in your words how you explain that down below, okay? And then on the next page, you'll be working with a binocular field of vision and a monocular field of vision. And again, you'll just be finding missing angles, okay? So now the next page is a challenge, but you guys are up for a good challenge. I know you can do it. So apply what you've learned over these past few days on using your benchmark angles, using things you know, to find a missing angle measure, okay? So I hope that helps you get started on page 274 and 275, okay? Go ahead and pause the video here, and when you're ready, we can look at page 276 together, which is some of the other part of your math journal that you'll have to do today. So once you're finished with page 274 and 275, you can play the video again, and I'll do a practice problem with you for the next part of your lesson today. All right, guys, I bet you flew through that first part. Good job. Now you're ready to start on the second part of your math journal pages today. So this part is called Finding the Distance. The table below shows the approximate distance in miles between downtown areas of different towns. Use the information to solve the following number stories. Show your work on a separate piece of paper. So now might be a good time to go grab that if you need it, or if you haven't already. You probably had some scratch paper to work on the other pages before, so if you have it handy, that's great. So let's take a look at this table and see what we know. So I see a lot of fractions, and then I see some missing pieces here. But these fractions are pretty big, and they're not just regular old fractions, they're what you call mixed numbers, right? Where you've got a whole number and a fraction together. So you're going to use this table to answer different types of number stories, okay? And you're going to be working with fractions. You've done that so many times this year. You guys are experts, so this is really good practice to really solidify, all the things that you've learned about fractions so far. And you probably haven't worked with some so big before, but don't let that scare you. Notice they all have the same denominator, so these are going to be easy to work with, okay? So before we jump in, let's look at our chart and see how to read it and to see what information is being told to us here. Now, remember, the chart shows you in miles the distance between downtown areas of different towns, okay? So you noticed earlier that there were some blank spaces. Well, if you look at the chart, those blank spaces are there because the distance from Deerfield to Deerfield, it's the same town. So that's why that's blank there or has an X there, because it matches up with the town. So if you see, you kind of read this like you would longitude and latitude maybe. So from Glencoe to Deerfield, it's 8 3/10 of a mile. Okay, so from Glencoe to Northbrook, you would go Glencoe all the way over until you get to Northbrook. It's right here. So it would be 5 7/10 of a mile. So are you seeing how this is being read? So from Park Ridge to Deerfield, trace till they meet up. So here's the Deerfield column, and here's the Park Ridge Road. So from Park Ridge to Deerfield, 13 6/10 of a mile. Northbrook to Northbrook. They're the same town. That's why it's blank. So what about Northbrook to Highland Park? You go over till you get to the Highland Park section. 6 5/10 of a mile. Okay, that's important to know how to actually read your chart before you start jumping in and doing the math problems. So, now that you've got a good idea of how to read this, let's look at number 1 together. What is the distance from Glencoe to Highland Park and back? Very important. So, if you go over Glencoe to Highland Park, is 4 1/10 mile. Is that our answer? No, because it asked us something very important. It said, and back. So if you went there, I can draw this out for you so it's easier to visualize. So here's Glencoe. Here's Highland Park. Okay, so you're a little person and you go there and back. How many times did you travel? Yeah, you traveled or you walked or drove or rode your scooter 2 times, right? You went there and back. So to figure that out, you could go about it a couple ways. I'm going to go about it the easiest and fastest way because that's how I like to work. All I did, so I know I traveled twice, and it's that same length every time. So all I need to do to set up this problem is 4 1/10 times 2, okay? Or you could do 4 1/10 plus 4 1/10, but I think multiplying would be the fastest way. So if I write that as a number model with an unknown, it would be 2 times 4 1/10. Now, to solve this, you're going to have to look back or think back. You can look in your SRB. Page 175 actually gives you the whole rundown of how to multiply mixed numbers, okay, by whole numbers. So here's our mixed number. We're timesing it by a whole number. So if you need to look back again, or if you need an extra refresher on how to do this type of problem, multiplying a mixed number by a whole number, you can do a couple of things. So your SRB, page 175, has an example and some practice problems you can do. You could also go back to my videos that I've been creating, my YouTube videos, and re-watch math lesson 7-5. That's where I taught you those two different ways to multiply a whole number by a mixed number. If you remember, there was an improper fraction way, and then there was a break apart way that I taught you. Now, the break apart way is my favorite way, so you can watch how I do that too, and that might be just enough refresher for you is just watching me do it. So I'm going to do the break apart way to solve this problem of 2 times 4 1/10. So I need to break up this fraction here, my mixed number here. So, So I'm going to write my problem 2 times 4 1/10, and then I'm going to come down here and break it apart. Remember, it's kind of like using the distributive property. So 2, and then I'm going to write 4 plus 1/10, just like this. I'm ready to set it up, okay? Don't want to forget my little time sign right there. Okay, so all you're doing is breaking this apart, and you're going to times each piece. So 2 times 4 is 8. You're right. And then now you need to do 2 times 1/10. So that's easy. When you're multiplying a whole number by a fraction, you just times the numerator and leave the denominator the same. So 2 times 1 is 2. Keep the denominator the same, and you're almost done. Now, you can't just leave it like this. You got to turn that into an actual fraction. I don't have any improper fractions here. I've got a whole number and a regular old fraction, so I can just pop those two together and get 8 2/10. And that is as easy as it is. It's so simple to do that break apart method to solve this type of problem. So your answer is 8 2/10 miles. Now, it also asks between which 2 whole numbers is this? So it starts off at 8. What's the next number after 8? 9. You're right. So is this number 8 2/10 in between whole number 8 and whole number 9? Yes. So a good answer for that would be 8 and 9. Okay? Now, not every problem that you complete using this chart will be a multiplication problem. It might be a subtraction problem. It might be an addition problem. But you have all the resources at your disposal to be successful. You have your SRB, and you can always go back and look at the different math lessons that we've covered so far. And there's all examples of how to work with those different kinds of fractions, okay? It's just one little YouTube away, okay? That's the beauty of having this technology, and hopefully all of you remember how to do it and don't have to look it up, but goodness, if you have to look it up, that's so okay. So feel free to look up anything that you need to look up that helps you get through this next set of problems, okay? So keep working hard, keep applying what you've known and what you've practiced all year. This is a longer lesson, but I know you guys can do this. You guys are becoming such great mathematicians, and I really think with all this good practice that you're doing that you're going to be more than ready for 5th grade next year, okay? So keep working hard. Remember to like and subscribe. Send me a comment. I miss you guys so much. Have a great time finishing this up, and I'll see you in the next lesson. Bye.